has been kind of stored, and let's say this slot has been consumed. So how the computer will know that how much memory of a stack that has been allocated to me is already consumed? So that's where this thing comes up. This one, the ESP register. ESP register. So this ESP register actually track what's the kind of like let's say what's the stage where the data, till what point the data is filled in the stack memory. So that is always tracked by the ESP register over here. Okay, by the ESP register in the CPU. Okay, that is what you are seeing over here, that the ESP is pointing to always to the top of the stack. So it is kind of keeping a track of, like let's say how much data has been kind of written to that stack, and it is keeping a track. So if you add more data, the ESP register will be coming more down. Okay, and that's why, so the ESP will always point to the top of the stack. Okay, and this is how the tracking will happen. Okay, so if you add another data over here, let's say in the stack, and it grows a little bit more, so the ESP will now point over here to this part. Okay, and it will always point to the top of the stack, how much it grows. So this is what you see over here. So a new data was added, let's say a new data was added over here. So what will happen, the ESP will grow a bit more. Okay, so if you will see the ESP, it will now point out to the highest part. So this is how it will keep track of like how much stack memory is full. So normally the stack memory, let's say, is something around, let's say 32 KB or 12 KB or 32 KB of memory is there for each process. And in that, and if you delete anything in that stack memory, the ESP will again come back and it will point out to the lower region. So ESP, the whole work of ESP basically is to kind of keep track of the stack memory. Okay, how much it has grown or how much it has like is empty. So that thing is something ESP will kind of keep track of. Okay, so now thing is that since we have looked at that, we have kind of covered the CPU and the memory a little bit in much more detail. And thing is that if you see like here it is written push and there's a pop. So it's actually, these are kind of an assembly instruction. If you see any kind of assembly instruction saying as push, that means the data that it is referring to the push, that data will be stored in the stack memory. Whenever you say pop, what it will do is that by default this instruction will remove out the first top values of that stack. So stack actually works in LIFO fashion. LIFO means last in, first out. So whatever thing has been last in, like this one, like let's say this was a last in. So after you push, it get last in, and when you pop, when you kind of exclude that, this is the only thing that will be kind of popped out first. Okay, and that's where the ESP will now point to the topmost value of the stack. So I hope it is now much clear in a sense that how the things look like. So we are again, like I'll just say, we are in the register part of CPU. Register part, we looked at like what are the general purpose register and all the details of what kind of different registers are there. We looked at in little bit much more depth what the EX register or any kind of register is all made about, like how it is separated out internally. And now when we are looking at the memory part, whenever a software is, let's say, loaded up in the RAM memory and it is executing in the RAM, and let's say that software is executing, this is how the memory of that software in the RAM memory will look like. So it will have the 6 sections over here, and in that we are dealing with the stack memory which grows from high to low. Okay, so this is all about kind of a brief introduction about kind of how the normal process work like. And now since we have kind of learned how this normal process work like, then we will kind of see how we can kind of exploit this architecture and get a remote code execution control of the system. Okay, so with that in mind, let's start our discussion with the next topic. So just give me 1 second. And guys, I understand this is very, very complex, and I have been devoting a lot of time in kind of setting up this lab for you guys. So if you guys don't kind of what to say, feel free to kind of ask questions. Don't keep any questions in your mind. Feel this is a chance to kind of ask questions and kind of let me know. Okay. So great, thanks. So let me just kind of go to the next data. Give me just 1 second. Okay, so now what we will be doing is that we will be looking at the stack memory in much deeper way. Okay, in much deeper way with this example. So I hope my screen is visible now, and let me go to that part. Okay, so let me go to the thing. Okay, so now I will try to explain the stack memory in a much more like kind of a little bit more deeper way. Okay, so thing is that let's say this is your code. Okay, this is your code. So give me 1 second. Give me just 1 second, guys. Let me see if I have one other tool. Okay, so now let me quickly go to this one. Let me share my screen. Okay, so what we are going to do now, we are going to understand the stack memory, how it grows, rather than on the assembly part, which might not be like all of you guys might not be comfortable with assembly instruction. We'll try to see that in much more layman terms from a coding perspective. Okay, and by coding perspective, I mean is that I mean this part. I hope this is visible. So this is the code over here. This is the code over here. And we'll try to see when this code execute, how the stack memory look like in different fashion. Okay. So this is all about the code, and we'll try to see how that thing look like in the stack memory. So when the code is executed one by one, let's say here you are also saying the functions are being called. So this code has a function. It's a very simple code where it is actually having a function called add me, and it is accepting two values a and b, where we are passing this value from here. A is 10 and 20, and we're passing that, and c is equal to a plus b, and then is returning certain values. And then once this function work is done, that's where the print line is kind of getting executed. So this is a very, very simple kind of code. Anyone, I think, will be able to understand. It's not assembly level code, and we'll try to see how the things look like in the. So this is what I'm telling is this is the stack memory. Okay, this is the stack memory in the detail, and this is something which we will need to kind of understand the thing. Okay, so thing is that, again, to reiterate, we will now see this part, this stack memory, in much more detail. Okay, so let me just go to that. So this is how the let's say the memory will look like in a normal sense. Let's say the code has not been executed. The stack memory is kind of like let's say totally clean. There is no data over here right now. So now the thing is that let's execute the line one by one. Okay. So what will happen is that when before this function is called, A and B, the argument that is 10 and 20 over here that is being passed to the function is actually